So today we're going to be solving some trigonometric identities, and this is for year 12 students. So if you're in your first year of A-level maths or further maths, this would be good for you because you'll only be covering sine, cos, and tan, and also the identity of sine squared theta plus cos squared theta equals 1. In your second year, you will be covering other identities and other trig ratios which you could use, but for your first year, this is what you'll be using. So now we are told to prove that sine squared x minus cos squared x is equal to 1 minus 2 cos squared x. Now, the way I like to solve this question is I like to look at what I have on both sides and see if there is a term that is on one side that is not on the other. So, for example, I have sine squared x. So I have a sine term on the left-hand side, but on the right-hand side, I don't have a sine term. So what that means is I could remove the sine term, and I know using this identity, which I've written, I can have my sine squared to equal to 1 minus cos squared x. So I'm going to replace that 1 minus cos squared x minus cos squared x, and that equals 1 minus 2 cos squared x. So yeah, that's nice and easy. Now, let's look at the one across. So now this one is sine squared theta minus cos theta sine theta tan theta equals 0. Now this one, clearly we can see that on one side there's a 0. So we have to use the opposite side. So we're going to start from the left and try and make sure we get to 0. So what I see here is sine squared theta. I'll keep that for now, but I have cos theta, sine theta, and tan theta. So let's try and simplify things on this side. So I know tan theta is going to give me sine over cos. So we can write that. So I'm going to keep the sine squared theta minus cos theta, sine theta, and we said tan equal to sine over cos theta. So sine over cos theta equals 0. So everything, my second term, I can cancel some terms out because what I don't want to make it as fractions. So I can put a 1 and put this over 1. Now cos and cos can go. So now I have sine squared theta minus sine squared theta, and that equals 0. So that is proved. Okay, let's keep going along and let's see what other questions we have. So this one now we have sine theta minus sine theta cos squared theta equals sine cube theta. So again, I can see, okay, on my right hand side I only have a sine term. Now on my left hand side I have a cos term and sine term. So this cos term I need to remove it. Okay, let's try to do that. Now, on my left-hand side, I have two terms, and both of these terms have a sine theta in common. So I could factorize it. So I'm going to have sine theta. I'm going to have 1 minus cos squared theta. And you know, 1 minus cos squared theta is sine squared theta. So sine theta, bracket, sine squared theta, is equal to sine cubed theta, which is what we have. Now, let's do question 5. So question 5, we have shown that 1 over cos squared x minus tan squared x is equal to 1. And you can't use the condition that cos x is equal to 0. The reason being, so this is an insight I'm going to share. In our calculators, anything divided by 0 is undefined. So if cos x was equal to 0, I'm going to have cos squared of 0. It's going to give 1 over 0. So therefore, if this is equal to 1, what I would like to do is to change this tan squared x into a fraction. So I'm going to have 1 minus cos squared x. Now tan is sine squared x over cos squared x. So now I'm going to have 1 minus sine squared x over cos squared x. and it's going to give me cos squared x over cos squared x. If I have the same term on top and underneath my fraction, it's equal to 1, which is what I have been given. Okay, let's look into a few more. So I've got tan theta sine theta plus cos theta is equal to 1 over cos theta. So again, I can see on my right hand side, I only have 1 over cos theta. Well, with that, we can't do anything with 1 over cos theta, really. So definitely we have to start from the left hand side and then work our way. So I know tan theta is the same as sine over cos. So I can do sine theta over cos theta times sine theta plus cos theta. Now, what I could do is have my sine squared theta over cos theta plus cos theta. Now, I want to make this cos theta as a fraction, so I'm going to put a 1 underneath, and that's going to equal to 1 over cos theta. Now, what I could do is, if I want to have the same denominator, I can multiply everything by cos theta. So if I multiply my sine theta, my sine squared theta over cos theta, this will give me sine squared. But now, if I multiply cos theta by cos theta, I'll also have underneath cos theta. So what I'm going to have is sine squared theta plus cos squared theta, and all of this over cos theta, because I want to have the same denominator. I'm essentially just done cross multiplication. So I've got sine squared theta plus cos squared theta over the common denominator, which is cos theta. Now, let's clean this up. So now sine squared theta plus cos squared theta is 1, and I'm going to have 1 over cos theta. Okay, so we have some nice ones here. Okay, so 8. So prove 1 over cos squared x with the square root over cos x is equal to tan x. So clearly, I want to get rid of the square root because on the right hand side there's no square root. So this is going to give me sine squared x with the square root over cos x. And I know if I square root sine squared x, it's going to give me sine x. So sine x over cos x is equal to tan x. Now the next one, I have 1 over tan theta plus tan theta is equal to 1 over cos theta sine theta. So now we have a tan underneath. Clearly, we have 1 over cos theta sine theta on the right hand side, and you can't really do anything with that because cos theta and sine theta is already in the simplest form. So let's do the following. If I know that tan theta is equal to sine over cos, now this is another insight. If I do 1 over tan theta, I'm going to have cos theta over sine theta because reciprocal. So I can rewrite this as cos theta over sine theta plus sine theta over cos theta. Now, as we've done in the previous question, I want to have the same denominator, so I'm going to literally I can do cross multiplication with these two fractions. So I'm going to have my cos theta multiplied by my cos theta and my sine theta multiplied by sine theta, and my denominator is going to be cos theta sine theta. So cos theta times cos theta plus sine theta times sine theta over sine theta cos theta. So I can see already I'm starting to get it into the form that I am required to have it on the opposite side. So let's continue. So cos squared cos theta times cos theta is cos squared theta plus sine theta times sine theta is sine squared theta. And we know cos squared theta plus sine squared theta equal to 1. And then underneath my denominator is sine theta cos theta and this would equal to 1 over sine theta cos theta, which is what we have. Now let's try this last one. So again, we're going through these questions very nice and simple, but you see the whole concept is just playing around with these identities in order to allow us to prove one side is equal to the other. Okay, now this is an interesting one. So we want to show that cos theta over 1 minus cos theta minus cos theta over 1 plus cos theta is equal to 2 over 2 tan squared theta. So yeah, even I was just reading it out is almost lost it there, but let's do it. So clearly, on my left-hand side, I could try and simplify these terms and get it into one whole term. So let's try that. So I'm going to write cos theta over 1 minus cos theta minus cos theta again over 1 plus cos theta. Now, what I could do, I can multiply both of these fractions by the denominator of the other fraction. So what I'm going to have is cos theta bracket 1 plus cos theta minus cos theta bracket 1 minus cos theta. And then underneath, I'm going to join my two denominators from the separate fractions, and I'm going to have 1 minus cos theta, and the second bracket 1 plus cos theta. So now let's clean this up and expand and simplify. So I'm going to have cos theta plus cos squared theta minus cos theta plus cos squared theta because of the signs. And then underneath, I'm going to have a difference of two squares. So we're going to multiply the first term in each bracket by each other and the last term in each bracket by each other. So 1 times 1 is 1, and then cos theta times cos theta is cos squared theta. And we're always going to have a negative sign. Now, this is looking good. So let's continue. Now I want to simplify the top. So we've got cos theta minus cos theta. That's going to cancel and equal 0. So I'm going to be left with 2 cos squared theta because cos squared plus cos squared is 2 cos squared. So 2 cos squared theta. Now underneath, I have 1 minus cos squared theta. So remember we said we can use our identities. If I know sine squared theta plus cos squared theta is equal to 1, I can literally rearrange this, and sine squared theta is equal to 1 minus cos squared theta. So this is going to equal to sine squared theta. Now I'm going to take this, and remember what's equal to 2 over tan squared. So the 2 will stay the same, but now if I have cos over sine, remember as we looked at earlier here, cos over sine is 1 over tan theta. But if I have cos squared theta over sine squared theta, it's going to give me 2 times 1 over tan squared theta. And this is going to equal to 2 over tan squared theta. And that is my answer. So, with these examples, I hope this was useful. And if you would like more questions like this, I'm happy to do another video. So comment below if you would like me to go over more questions as difficult as this, or even more challenging questions. I'm happy to solve them for you, and you can see the insights that I've displayed in the video. So thank you very much, and subscribe, and I'll see you on the next one.